Well, hello. I'm not here to profess any kind of expertise. I have none. But I'm here because I read a book earlier this year and I enjoyed it so much that I read it again straight away. It's called How to Stay Smart in a Smart World. If you can see that, get that just about in the right place. By Professor Gerd Gigerenzer, who's a professor of psychology and risk studies. And what it is a toolkit for analyzing or questioning any number of tech solutions which come down the pipe. We're bombarded with them every day. I mean, if you hear that the police are going to be using facial recognition to weed criminals out from crowds, is that a good idea? Will it even work? How soon will we have driverless cars? Will we ever have driverless cars? The book addresses things from a point of expertise, and it makes it easy for you to join in with that and actually ask questions of what we're being given, offered, or maybe hustled. It also gives you tools to decode misinformation. 96% of digital natives do not know how to interrogate the website that they're reading or the posts that they're reading to find out whether they might be true or not. So it's a great book, and I'd like to start in the middle, if that's all right with you, Gerd, and ask, would you put an artificial intelligence in charge of making the decision to launch nuclear weapons?
No. No.
And why not?
No. There are certainly some humans I also would not want to put in charge. But the problem is with AI, so precisely the technology we have today, which is called deep artificial neural networks, that they are a statistical machine that works on associations and correlations and is very different from a human mind. So just to illustrate, it makes errors that we never expect. And that's the key problem. So in today's AI, you cannot put an AI in charge of important decisions. And most important, it's not the AI, it's the people behind the AI whom you put into charge. AI doesn't make decisions by itself. There's always someone who is behind it, uses it for their own interests.
So if, for example, somebody said, well, the AI has a much more complex field of data to read and can process all of this in unimaginably clever ways and produce a better outcome than a human mind, what would you say?
Well, that's not true. So let's start. The usual argument that AI would be superior or soon be or is already to human thinking goes this way. So the first assumption is that AI has beaten the best humans in chess and Go, which is true. Second, computing power doubles every 2 years or so, which is also true. And the conclusion from that is that soon AI will do everything better and match any kind of human intelligence. And that's the super intelligence argument. The conclusion is wrong. So deep neural networks and other forms of AI are statistical machines, and they can do some things, but not everything. They are excellent when the problem is well defined, as in chess and Go. When it's a routine application, when the future is like the past. But big data misleads you if the future is not like the past. So we still need human intelligence because we can think about the thing. We have a concept. When a deep neural network recognizes, say, can tell school buses from other vehicles, it nevertheless has not a concept of a school bus like we have. It works by associations between pixels and groups of pixels. It's a statistical machine. And that's a very different kind of intelligence, if one at all.
Ah, that's interesting. So the question even is on the term, is it a kind of intelligence, or is it just a number crunching device which sometimes goes out of sight because it's disappeared within a neural network, but is nonetheless merely a sort of statistical refining machine?
Yeah, it's a powerful number crunching machine, yes. And this is nothing bad. We can use that, but we should not fall prey to the marketing hype.
And that's what it is. Sorry.
That's what it's usually, that it can do everything. So one example, think about IBM's Watson, the supercomputer, who beat the best humans in the game Jeopardy. That was a great achievement. But then you can't earn much money with Jeopardy. So IBM CEO, Ginny Rometty, she announced the moonshot. Now Watson will go into healthcare and revolutionize medicine. Not because Watson knew much about it, but that's where the money is. And then Watson Oncology was offered to hospitals to advise them for cancer therapy. And naive heads of hospitals bought Watson only to learn within short time that some of the recommendations were threatening the lives of patients. And at the end, IBM admitted that Watson is at the level of a first-year graduate student. So NIH Anderson, a well-respected cancer clinic in the US, spent $62 million on the first-year graduate student, and only then realized that it's marketing hype and not something that this AI can do.
Plus, a first-year student might well know that they don't know what they don't know.
Yes, yeah. But again, it's not the AI, it's the people behind it. In this case, the marketing department.
Well, exactly. Sorry to interrupt, but so that example of Watson hasn't stopped similar things being pushed all the time. And in the field of medicine, you often hear there was an app here called Babylon, which was going to revolutionize medicine and was going to replace general practitioners or make other medical decisions because it was a clever machine and it could do it. That's rather collapsed, I'm pleased to say, but it didn't stop it being brought in by the health department and pushed for about 10 years.
Yeah. So the key distinction to understand what these complex AI machines can do and what they cannot do is what I call the stable world principle. So take Watson. The game Jeopardy is a fairly stable world, and actually the rules of Jeopardy had to be made simpler in order to give Watson a chance to win. And in these worlds, AI is superior to humans. When it comes to unstable worlds, where uncertainties like cancer therapy or like human behavior predicting who will commit the next crime or something like that, then the results show clearly that AI isn't better than human expertise. And also I would add, it won't be in the near future. But the problem is that the companies try to market it in this area. And if you are a smart head of a hospital, then you ask yourself, is this application for something like, what is a stable world? For instance, the documenting and archiving data, that's fine. So patient records, for instance. But is it for something which is not of this kind, like cancer therapy? Then keep your fingers off. It's likely marketing hype.
Well, that's the thing, is that the marketing hype, it sounds like you're saying that it's present in every sector. So it's present in professional sector, but it's also present culturally, so that we all experience a degree of pressure to accept that the technology will sort things out for us.
Yeah. there is also a kind of techno-religious faith. So there are some of my dear friends who live in California. They really think that at some point AI will make them immortal.
Okay.
So they can
Yeah.
upload their brains into a super intelligence. Not really considering if there would be a super intelligence, which there will not, but assume it would be one, why would it be interesting to have your stupid brain embodied in it? So
yeah.
and,
So they'd be better off uploading it to a. They'd probably get a better reception from an animal brain than currently than they'd better uploading it to a dog.
Yeah.
Than an AI. But why do they? Okay, these intelligent people. Why do they believe that? Just because they don't want to die?
Look, much of what we do is not driven by reasoning, but by desires that we have. And the desire to be not to be immortal is an old one. And we have, in the history of technology, always had all kind of hopes on new technology, for instance, genetic technology until recently, so that we might end up immortal. And so that just makes it difficult for these people to think rationally. And these are the two major factors. So marketing hype and techno-religious faith that prevent us from seeing, here are. So AI applications can do wonderful things, but they can't do everything.
So I'd like to read you a quote, which I'm sure you'll recognize, and ask you whether you would categorize it as an article of techno-religious faith. It's a quote that is proposing that big data can replace traditional scientific thinking. And it says, out with every theory of human behavior, from linguistics to sociology. Forget taxonomy, ontology, psychology. With enough data, the numbers speak for themselves.
Yeah, that's from the former chief editor of Wired, Chris Anderson. Yeah. And it's plainly wrong. So, I mean, the data doesn't speak for itself. For every big data application, like predicting the outcomes of the next presidential election in the US, every statistician knows that you have to make assumptions about the data. What kind of distribution do you assume? Do you assume fat tails or normal distributions? How much data, how much back do you do? And those who are real statisticians, they know that the results will depend on all of these assumptions, and you cannot make no assumption. So that's the first thing. And the second thing is the big data only works in stable worlds. So if tomorrow is in an unpredictable way different from yesterday, all your big data, which is always from the past, doesn't help. It misleads you. And I've given in the book one example that we did. It's about the prediction of the flu. The flu is an unstable virus which doesn't behave properly and surprises us all the time. And there's no point to use big data. You need to use simple algorithms so that are robust and they can do better than big data.
This is a very strong point, though, because it applies across the board, doesn't it? So whether you're talking about predictive policing, where you're trying to use statistics, postcodes, recidivism, or previous crimes to predict the future, but also that there was a famous study, wasn't there, on trying to predict the outcomes of children in schools by looking at quite a large number of data points.
Yeah.
And I can't remember, Gerd, if this is in your book or another one that I read recently, but the prediction using 13,000 data points was no better than the prediction using 4 data points.
Yeah,
and either way, those predictions were only 20% right. Is that correct?
Yeah, that's right. That was a challenge by Princeton scholars who provided data on so-called fragile families, so usually single parent families, and with some 12,000 data points for each family. There were lots of families. And then they made a challenge, predict now what will happen with the child, what will happen with the family, will they lose their home, and all things then you can verify. And the result was exactly as you said. The best and most complex big data analytic methods were not better than simple rules that use just 2, 3, or 4 variables, period. And that's typical for uncertain worlds. In uncertain worlds, you need to simplify. You don't win if you made it more complex. And simplify means you need to find the few powerful variables that actually help you to predict. Big data is an illusion in this world.
Well, that's a pretty powerful point. I mean, generally, because I think big data is used for all sorts of programs or decision making, or I mean, even down to advertising, the sort of the business models of social networks and search engines and so on. Would you question the efficacy of those too in relation, say, to advertising?
Well, again, if you're in a stable situation, big data will work. So if you just analyze if people do the same behavior again, or in industry applications, it will do well. We can analyze who is buying which books, and if you buy one book, that correlates with how many of the others have also bought these books and which book have they bought, and you get a recommendation. That may work. There is little instability in it. Although these algorithms they just calculate associations. They're not thinking. Otherwise, I wouldn't get always my own books recommended when I search on Amazon. It just doesn't get the point. But that's you can't expect that from an algorithm. And it's not like a human who has common sense. And that's the hardest for AI. So big data works in situations where there's stability. For an astronomy, heavenly bodies, they're not really affected by us, at least till now. But if the future is uncertain, then forget it. And for instance, we showed that you can predict the flu better with a single data point than with Google Flu Trends big data analytics over the 8 years. It's one data point. And the flu is not a stable virus.
But that's really important. That sort of goes to your point about common sense and instinct in relation to artificial intelligence.
Yeah. So, I mean, the positive news is that human intelligence is so different, and in situations of uncertainty, so much superior to all that we have as AI, that we are still being needed on this planet, and for a long time. and the challenge is to understand what's different. So human intelligence, we think causally. We always ask questions. Even children ask why? Why do I have to eat broccoli? Why are the neighbors rich and we not? And the deep neural networks, which are statistical machines, they only analyze correlations. That's one difference. And also we have
sorry, may I just interrupt? That seems to be a fundamental point that gets overlooked again and again. I mean, it's a very basic principle that you definitely need to look at cause and effect. I mean, that's how, as you say, that's how we live, how we think. If you just override that and just say, well, It just so happens that if you paint all the buses blue in this city, then the crime rate goes down. I don't know why, but let's paint all the buses blue.
Yeah.
You've not really discovered anything, and then when that goes wrong, you don't know why it's gone wrong.
Right. And we have seen in the best deep neural networks that they sometimes find a cue to make a classification that's totally irrelevant. So there is an urban legend that illustrates that. It's called the Russian tank fallacy. So allegedly, the US military wanted to have a system that can tell US from Russian tanks. And so they gave, they had thousands or 10,000 of photos of Russian tanks and of US tanks. And at the end, so this network learned on maybe one half of the pictures and other tested on the other one. That's called out of sample prediction. And it worked wonderful. And then it was tested in the real world, and it didn't work at all. So later it was discovered that the network, so that the pictures taken of the Russian tanks were on a cloudy day, and the pictures taken of the US tanks on a sunny day. And the network had picked the decisive cue, clouds. See? That's statistical intelligence. We would never even think about that as a usual cue.
But this happens a lot, doesn't it? I mean, there's the case, the diagnostic case in relation to pneumonia and X-rays, where something similar happened, isn't it?
Yeah, it has happened. It's been shown in real cases. The Russian story is just one that's easier to understand. So, for instance, in the pneumonia studies, again, a network did very well in being tested on pictures of patients and with new pictures, and then it was used in a different hospital, and it was a flaw. And the later one found out that it has detected whether the pictures, the X-rays in the original hospital were done in the X-ray department or with a portable X-ray. And the portable X-rays were only used for patients which couldn't walk in severe conditions, in this case with likely pneumonia. And so that's a cue that helped in the one hospital, but was irrelevant in the next one where there were no portable X-rays. So there are many real stories that that show that this kind of intelligence, knowing where to look and what's relevant and what's not relevant, is not part of the best neural networks.
So how would that apply to driverless cars?
Yeah, in the same way. For instance, one task a driverless car would have to solve is to tell children from other objects on the street, to tell school buses from regular vehicles and so on. And here the networks who do well in the laboratory with they're trained on pictures in this case, they can be fooled by so-called adversarial algorithms. So that find out what's the weakness of the networks. And the weakness of the networks is its lack of a concept of a child or of a school bus. And there are, for instance, situations where you can, so take an American school bus whose colors are yellowish, and there is a black frame. And if you show a neural network that has learned on pictures perfectly to tell school buses from no school buses, give it a picture that has just a horizontal stripes, a yellow, black, yellow, black, yellow, black, just stripes. And it thinks it's 99% sure that this is a school bus. So that tells us the following things. Neural networks make errors that humans would never anticipate. We make different errors. Behind the driving wheel, people are drunk, people don't pay attention, they're on their smartphone, and whatever, they're tired. None of this would apply to a machine. But they make very different networks. And that's one of the key problems for the safety of autonomous cars.
So what do you think the, say, modern urban landscape will look like in 10 years' time in relation to driverless vehicles?
Yeah. So I think there will be no self-driving cars, but something much more interesting. So let's be clear. The term self-driving cars is used for all kinds of things. In the international classification, it means level 5, that's the highest level, and where a car can drive without a human paying attention and safely under all traffic conditions. That's 5. We at the moment have level 2. Level 1 is like one feature, distance control. Yeah? Level 2 is integrate many features into, say, automatic parking. Level 3 would be a car that can do everything that's needed for driving, but still a human has to pay attention second for second if something happens. Level 4 is, in my view, our future and the most interesting one. It is cars that can drive without humans, but only in restricted and well-prepared parts of a city or highways. And so, we do have some level 4 cars in well-restricted areas. And the big problems for level 4, just as any autonomous cars, are human drivers. So while level 5 is a fiction that almost everyone has given up except Elon Musk, who still promises every year that next year will be level 5 driving somehow, which is techno fantasy. But journalists reproduce this mindlessly. Something much more interesting will happen than this gimmick of level 5. Level 4. Level 4 will demand that we change and that our environment, say the urban landscape, will be changed. So, for instance, parts of cities will be opened to level 4 cars. That means that no human is allowed to drive in this area. And if it's the entire city and the entire urban landscape, then humans are forbidden to be behind the steering wheels because we are the problem for that. Also, these areas need to be sealed off from pedestrians, from cyclists, from animals, from anything, in order to adapt to the limited capabilities of these level 4 cars.
Why don't we all just move out then and just leave that part of town to the cars and they can get on with it? I mean, if you got rid of drivers, pedestrians, cyclists as well, I mean, you're sort of describing a monorail or something like that.
Yeah, so that would be pedestrians and cyclists would still be in that part, but they would be sealed off. It's okay. like highways are sealed off, and even more. And then these cars will probably be quite slow to drive safe, and the vision. If you ask me, what could my vision if we still keep cars? That's another thing. Then we might have level 4 cars that zip around. We can call them, sit in them. They transport us to faster technology like trains or public transport.
Right.
That can do faster. So it will be the short-term taxis that may be quite convenient, but look, it may result in the fact that humans are no longer allowed to drive.
But Gerd, so a human being gets into one of these cars that's in a sealed off area where there are no pedestrians, no cyclists, and no human drivers. But at a certain point, they've got to get out of the car, at which point they'd become a pedestrian in close vicinity to the car.
Yeah, right.
So presumably everything would have to stop.
Yeah, right. That problem has to be solved. Yeah, the car might stop at a bus at a railway station. Yeah,
Right.
I think that could be solved. Yeah? And we might have these fast trains like Japan has, the Shinkansen, real fast trains, and you don't need planes.
Well, that's more interesting because I think, once you have a sort of multi-portal station, shall we say, where you've got 30 driverless cars, each of one docks in a port, and the pedestrian can get out and through the gateway. You're sort of a train without coupling, basically.
Yeah, and that would be really a benefit for the environment. If you have trains are anyhow electric, and if you have fast trains instead of planes for distances of a few hundred miles, and also just imagine if that is in place. So your children or your grandchildren will ask you, Daddy, is it really true that when you were young, people were behind steering wheels and drove themselves and killed other people? And it's all gone.
So you actually think that you can imagine a future where every form of transportation is within a preordained track, as it were, if not an actual railway line, then a road that has some similarities to a railway line, and everything else is verboten or in some way or excluded elsewhere. You'd have cycle accidents, but you wouldn't have vehicle accidents.
So let's say most of transportation, there will be always some exception in some extreme remote areas, but that could be a reasonable vision of how it might look in the future. Certainly, it won't be self-driving cars. It is the level 4 cars. They are an example of what's really the interesting thing is, namely, I call this the adapt to AI principle. AI is not just an assistance tool. We adapt to the technology. In that case, we stop driving and we change our cities. And some cities in Japan and in China are at the moment being designed for this type of living.
Yes, I mean, that feels like you can argue that as a positive adjustment in behavior in relation to quite a lot of technological influences on our behavior, which are negative or push us into spaces psychologically where we are not best served by the technology. I'm talking about social media and the interests of, I guess, an advertising industry pushing around.
No, there's no question that there are many. I mean, we couldn't do this conversation online if we wouldn't have digital technology. I personally, in my research, I benefit huge from that. But the point is, the one needs to keep, one needs to distinguish between the good things it can do and what's marketing hype or techno-religious faith. That's the important thing. And also that it's being used, since you mentioned teenagers and many other people who get dependent on certain social media and on the clicks, and you feel an urge to look every minute, whether they got another thumbs up, or another like, and that's something that worries me. And these things, they could be avoided or reduced to some degree if the tech companies, the social media companies, would change their business models.
Yeah, and make it, and so you would have to pay for the service.
Yeah, right.
Because advertising wasn't the way they made money. And it's interesting. I know you noted in the book that when Google started off, the people who came up with Google were against using advertising because they foresaw it as a problem in relation to a search engine.
Yeah, Larry Page and Brin, they wrote still in 1998 an article emphasizing that search machines should be scientifically based, not advertising based. And they should be for the common good and not for the benefits of the advertisers. They were criticizing others who already then made their money from advertisement because, as I said, a search engine that's financed by advertisers will serve their goals and not in the first line the goals of the users. But then the dot-com crisis came and they got under financial pressure and they turned around 180 degrees and built the most successful personal advertising search engine.
Yeah, and a lot followed from that, didn't it? I'm just wondering, I've seen that time's limited, but there's two more things I want to look at. One of them you almost alluded to in relation to a lot of this stuff being sold and sort of benefiting the people who are selling it as opposed to the people who are using it. But do you have a kind of way yourself of confronting aspects of technology and I guess protecting yourself from falling into some of the pitfalls that you've outlined in the book?
Yeah, so I mean, you can either not spend your life on social media, just do the minimum, or just have good friends in person, and talk with them, and also develop a conception of yourself that your self-esteem must not be dependent on the number of likes and comments you get on your posts, and also think about getting independent from the business model of the big tech companies, which require that you are constantly on the platform to see advertisement as much as possible. And then there are many other things. So we are trying to teach people risk literacy in general, also digital risk literacy. And for instance, studies show that 50% of digital natives in Stanford even don't know that when they're searching for something important, that the first search entry is not the one that's the most relevant. It's also not the one that's the most popular. It's the one that, say, if it's Google, that the Google search engine calculates that it makes most money out of it. So there's a lack of an understanding of the nature of the algorithms. And also, even 96% in one study of digital natives in Stanford do not know how to check the trustworthiness of a website. They look at it, it looks cool, rather than doing lateral reasoning. Go out of it, go behind it, find out what's done with you.
But I think don't you have a rule of 3 or 4 just very simple checks you can apply? I know you were trying to teach this in various schools that people of any age can apply, particularly young people, to interrogate the reliability of what they're reading.
Yeah, and you might ask why it's not being taught anywhere. So countries spend billions in getting tablets and whiteboards into the schools. There's no evidence that tablets increase the grades of the pupils. Rather, there's evidence that they decrease the grades. What helps is technology for the teacher, whiteboards. That's useful. And why tablets don't help? I mean, you can just imagine that. What do pupils do on the tablets? But the most important thing is, if we want to have smart technology and control it, we need to have smart people. We need to invest in young people, in adults, into everyone, including into politicians and journalists, that they finally understand the digital world, rather than being, in the case of many journalists, just repeat what a tech industry told them.
That's a pretty tall order, Gerd, and I see that we're out of time, but it's a good note to end on. I look forward very much to your next book, and I'll probably read this one again. It's full of great stuff, and we've only covered some of it, but thank you very much for your time.
Yeah, stay smart.